there's a ton of responsibility in being an engineer and putting your name on that said, yeah, I checked this backwards and forwards and this is gonna work, and it's something I'm proud of.
When we get the call and says, hey, we need to fix this thing here it's been a problem for years, and we've talked to other people, they don't know what to do. Can you help us fix it? Man, roll up the sleeves, let's get in at it and go. And that's I think what drives people, because we do some really neat stuff, some really unique solutions.
Yeah, we're willing to take on anything.
Every client's project.
Good morning. I wanted to welcome you and appreciate you turning in for Basics of Industrial Automation. Subject matter expert today will be Pat McAvoy, who heads up the electrical group within CDG Engineers. A couple of housekeeping items. If you will, there's a chat box or a click on your screen. If you have questions, please submit them in chat. We will wait until the end of the presentation, then get to all of the questions. With that, I want to turn it over to Pat McAvoy. Pat?
Hi, good morning. How are you? I hope everyone's doing well. My name is Pat McAvoy. I'm the manager of the electrical engineering department at CDG. I'm coming to you from our former baby's room, now office. So I hope everyone's in similar conditions and doing well. But I'll go ahead and get started. I've been in the business for about 12 years, and background is more in power and controls engineering. We do a lot of arc flash studies as well. And we are a pretty diverse group and have a lot of experience in a variety of fields. But today I'm going to talk about industrial automation, a high level view. If you're a controls engineer, you probably already have a lot of relevant knowledge to what I'm going to be talking about, but hopefully you can find something interesting out of this. I will go ahead and get started. All right, if you don't know about CDG Engineers, it's a full-service, multidiscipline professional services organization. We've got capabilities in civil, structural, mechanical, and electrical engineering, as well as architecture. And our services include planning, engineering, architectural design, construction administration, typically in the fields of infrastructure, power, mining, heavy industrial type fields. We, as a company, have been around since 1992. We have roots going back to 1941. We are a full-service firm. Most of our business is repeat business, and we got pretty low employee turnover. Most of our folks stick around for, on average, about 7 years or so. An overview of our electrical group. So we recently just kind of divvied this up a little bit. We used to be one group managed by Kevin Cox, but we recently just split up this year into two different groups. So our one group is the utility services, and Kevin is director of utility services. I manage the electrical engineering group. Kevin's been around for about 15 plus years. His experiences in low voltage power design, integrated resource planning is kind of his bailiwick. And I've been around for about 12 years. I've got a lot of project management experience, a lot of power controls engineering type work, and arc flash and SCAM modeling, and also ETAP type modeling. So we recently split to kind of focus each group on kind of what they're good at. So the electrical engineering department is now about 8 staff. We have 4 licensed electrical engineers, and our specialty is focused around power engineering, controls engineering, retrofit type design, integrating new designs into an existing system or facility, arc flash and safety, and kind of troubleshooting. The utility services group, they have about 9 staff, and their focus is more on substation and T&D automation and doing relay testing and commissioning. We have about 3 folks that do that. We have integrated resource planning, and we also have about 4 individuals that do contract services at some client sites. So that's a little bit about who CDG is and kind of what our electrical engineering folks do. So industrial automation. So I'm just going to kind of briefly cover the differences between SCADA and DCS and PLCs. Some example industrial automation systems that we see a lot in our line of work, and then some interesting projects that CDG has done in the past. So industrial automation overview. So what you generally see is SCADA, DCS, and PLCs. Now these are all kind of blending as computers have advanced significantly since they were first, created 30 or 40 years ago. The lines have they aren't as black and white anymore. But SCADA is supervisory control and data acquisition. DCS is your distributed control system, and PLCs are your programmable logic controllers. The big difference between these three is really SCADA versus DCS and PLCs. And historically, the difference has been that SCADA is really a data gathering, as it says in the name, it's a data acquisition type platform. It is really just pulling in information and displaying that typically on an HMI or maybe an annunciator panel. DCS and PLCs are more process control related, so they will be a hardware and software solution, whereas SCADA is typically going to be just a software solution. SCADA came about because of accessing remote sites. So in the utility industry, and power utilities or wastewater treatment type sites, you have a lot of remote locations, and it's typically just overcurrent protection, or it's a small process at like a pump station or a lift station. And so folks needed a way to get all that information back to a central location. So that's how SCADA came about. It's typically software on top of hardware, and you'll see a lot more various protocols and softwares. So there's a lot more, much more options, I think, for SCADA than you might see for a DCS or PLC system. And that pulls it in over software via communications. It could be over the air, cellular or radio, or a hard line like a fiber connection. And it takes all that information to a central location and gives you feedback on all your remote sites. DCS and PLCs, like I said, are process control. You'll see DCS systems in what I would kind of call a more continuous process control, whereas PLCs are kind of discrete, meaning they're standalone type systems, whereas a DCS system is going to be a much more complex type process that it might control. So producing power, right? You're going to need something that controls the steam generation, the boiler operations, the turbine controls, ash handling. It's got a lot of different pieces going in, a lot of different information going to one central location, and multiple control systems throughout the entire facility. Whereas a PLC is likely going to be a more standalone system, a more dedicated process. So it might be a transfer house at a coal mine, or it might be a crushing or a loadout type setup, where all it needs is maybe a few hardwired alarms from something upstream to tell when it needs to run. So DCS is going to have tens of thousands of inputs and outputs, whereas PLC might have a few thousand. And that gets into the support between the two. DCSs are really going to be supported by the DCS vendor, whoever sells you the product or makes your DCS system. So it's going to be an Emerson or a ABB Bailey type. They will come in and support and install the DCS system itself, or it might be, there are some consultants that do it, and they are typically former folks that used to work at the DCS vendor's location. It's a high capital cost to entry in order to get familiar with the DCS system. PLCs are typically going to be supported by a system integrator, usually a consultant, similar to CDG. There are plenty of control outfits that are PLC focused, and they can support a variety of PLC systems, but it is typically not as common to have a PLC vendor also come and support and manage your PLC system and control system. Another difference between the two for SCADA and DCS and PLCs is single site focused versus remote locations, like I said. So a DCS is really going to be at a central location, or a PLC system is going to be at a central location. It might communicate some information back to another site via radio or cellular communication, but really it's not going to control. A DCS is going to control 400 different sites. It's going to really control one site, and it's just too much I/O, too much traffic on that communication stream to take all that control process over a communication network. So some example industrial automation systems that we typically see and deal with. This is really industrial focused, not so much commercial focused. So a large industrial facility, so a power plant or a wastewater, it's really going to be controlled by a DCS process. It can serve also SCADA functions. So it'll control the whole process. It'll turn on motors and pumps and run conveying systems and control the turbine and that sort of thing. And it can also serve as a SCADA function. It'll display all that via an HMI at the control room and tell you what's happening out at your various equipment. It can also take in PLC or third-party or intelligent device type systems. So you can have a PLC system that just runs maybe the ash handling or a standalone process that you don't really need. That's not really critical to the power plant operations, but you can take in that information to the DCS and communicate it to your operator folks. It's a master controller. It'll operate all parts of the process, like I said before. So it'll operate all the the turbine control, the boiler operations, ash handling, emissions, that sort of thing. So CDG is not really a DCS focused company. We don't do that ourselves, but we can help out a lot with the relaying systems you have. So you might take all your relaying that controls or that protects your medium voltage equipment and motors, transformers, your MCCs, anything that has the ability to communicate. We can help in that respect as far as taking your alarms back to your DCS system from your various relays or protection schemes out in the plant. Another one we deal with a lot or see a lot is transmission and distribution. So these would be your utilities, municipalities, and this is where SCADA kind of reigns supreme. So it's going to really be a SCADA network with remote substations. So you're going to have reclosers, circuit breakers out in the field at a substation or a distributed energy resource. And by that, I mean a solar farm or a wind farm. Remote switchgear. If you've got a large enough remote site that's got some medium voltage switchgear that protects transformers, downstream transformers, that stuff typically does not communicate back to a central automation system. It's just there to protect. But you can put it in a remote terminal unit, an RTU, and communicate that stuff via SCADA if it's fiber or remote or wireless type communication back to your central hub. So that way you can know what's going on out in your field. If your breakers opened up, if your reclosers operated, if your something's tripped for a long time trip sitting, it's been overloaded or that sort of thing. You can also take in some process control operations. So if you have like a PLC at a remote substation or remote pump station, or you have a lift station of some sort, you need to know what's going on with that PLC, you can take that back easily via SCADA and monitor what's going on. CDG can help out quite a bit on the T&D side of things, and SCADA type networks. That's what our utility services group is around for. So they can take any kind of master terminal unit and RTUs type system at a substation or a distribution type location and take it back to a main central location and all the communications in between, set up the network. All that our utility services department can do that. The last one I got is for other industrial type facilities. So manufacturing, mining, maybe more of a heavy kind of commercial type facility. These are most likely going to be PLC control system. DCSs have a high cost to entry, but PLCs, there's a lot more variety with PLCs, and the costs can vary from manufacturer to manufacturer. So you'll see this in places that may only have a few hundred I/O points. You'll almost always see a PLC type system. You can have a single CPU with remote I/O that controls the whole process. You can have multiple CPUs that can communicate over a network, Ethernet, Modbus, fiber, any kind of various protocol or hardline or fiber or radio type deal. So we'll see it a lot. Our experience is our background is typically in mining, so you might have a PLC system that controls your loadout, your conveying operations, and your transfer. But these don't necessarily, the PLC systems don't necessarily all have to be, it's not a giant process where they all need to communicate back to a central location to operate it. They can operate independently of each other. So your transfer operations can just take a hardwired input or two or a dozen from like a belt trip or a speed switch from the conveying system up above and tell it when to operate or when not to operate. Same with your loadout. It can just operate independently of the conveying system that feeds it. They don't necessarily need to all operate in unison as one. So CDG has a good amount of PLC experience. That's where our typical controls background, our general controls background is in. So the whole PLC control automation process from control narratives and coming out with the system architecture to programming and commissioning startup, we have a lot of experience in that. Some interesting projects that we've done in the past, some wireless automation. One great example we have is Wolf Mountain Coal. We had a wireless PLC installation. This was for a new conveying system for Stoker Coal out there. They had conveying equipment, instrumentation. They were putting in new stackers, feeders, and crushers. And they wanted a cost-effective solution, so they ended up putting in a Phoenix Contact inline PLC, and they used 5 gigahertz radio communication between the PLC panels. There was only about 250 I/O points, so that made radio pretty good. If a giant system may not be as ideal for a radio communication. We did the PLC programming with PCWorks and the HMI programming with VisView Plus. Both of those are Phoenix products. And like I said, it was pretty cost-effective solution. It was pretty cheap and it worked out pretty well. They're still operating today. This was a couple years ago that this went in. Good example of some automation retrofits. So a good example that Dil Kabede from our utility service group has done is an RTU upgrade for Amarillo, Illinois, where they replaced an existing capacitor bank controller relays. And so what was interesting about that project was that it was a retrofit and also added remote monitoring capability. So they were able to make it wireless. So they added remote monitoring capability with an RTU and cellular communication. They did the relay testing. The new system was an SEL 2411 with some GE iBox RTUs and some remote monitoring. So that was a pretty good project for Dil to get done. It kind of had the best of both examples there. The last example I got is for Doron Blast Furnace. Doron is no more. The plant finally had to close down, and they moved the stuff outside the country. But this was a PLC system upgrade. A pretty interesting retrofit in that they had the existing control system had relay logic, it had a DCS system, and it also had some PLC systems all sprinkled throughout the site. So they had the Delta V stuff that operated the TWIR controls on the blast furnace. They had relay logic for some pretty old legacy conveying operations, and then they had a PLC system for some lead handling kind of stuff. So they had no monitoring, they had no trending, they had no alarm capability. So they were in pretty good need of a controls upgrade. So we were able to replace all 5 PLC systems, the relay logic cabinets, and the Delta V TWIR control cabinets with a single control solution using a PLC system. All the cabinets stayed in place. For the most part, the existing wiring all stayed in place. It was all in decent condition. We replaced some communications Ethernet cables in some spots, but for the most part, most of the wiring and raceway infrastructure stayed in place. We just reused the cabinets. Put in new control logics PLCs from Rockwell Automation. We did all the HMI with factory talk site edition. It was all Ethernet communications. So it was all said and done. They got a new HMI, new history, new trending, a new PLC system that was the same throughout the entire facility. And that worked out really well for them. They were pretty happy with that at the end. So, and then CDG does have a lab. It's empty generally for the most part because everybody's working from home. But this is where we do a lot of our relay testing and configuration. We have a lot of SEL equipment. We also have some PLC equipment. You can't see it in this one. It's in the photo that behind the person that took the photo. But we have some PLCs set up to the back right that can that we use for simulation and programming and setting up our controls automation products or projects. So that's all I got. So CDG, our main headquarters is in St. Louis in South City. And we got an office in Sheridan, Wyoming, out in the Powder River Basin. And that's it. Thank you for the time. Are there any questions?
Thanks, Pat, and thanks for everybody watching. We did have a couple of questions emailed in advance, and I'll read those off for you. First question is, what PLC systems do you have the most experience with?
Our background is mainly in Rockwell Automation. We have probably the most experience with that. We've done a little bit with Modicon, Schneider stuff, Modicon, and some vintage, I guess, Modicon stuff like PC Works 32. But for the most part, it's Rockwell Automation. We're technically a system integrator for Phoenix Contacts. We do have Phoenix Contact experience. But for large industrial sites, we typically see Rockwell a lot, and that's where our majority of our experience is with.